Speed is a word that defines the 21st century. We want speed in everything we do, be it in our personal lives or the business we conduct, you name it. Fast cars, fast computers, fast lanes, fast internet connections, and so on. In tandem with today's fast-paced world, database sizes have increased as businesses have found value in keeping historical data longer, sometimes forever, for various analysis to gain a competitive edge. Databases that do not scale well often result in higher processing time in spite of the availability of better and more reliable hardware. These issues eventually flow downstream and quite often are relabeled as database performance problems. Corporate IT organizations expect DBAs to possess the required know-how and be available 24/7 for speedy resolution of all performance problems. Due to this, performance monitoring and optimization functions have gained prominence and consume most of a DBA's time. DBAs need reliable performance monitoring and tuning methods. Oracle fulfilled this requirement by architecting the Oracle Weight Interface, OWI, to help DBAs quickly and effectively diagnose performance problems. This course is all about the Oracle Weight Interface. It gives DBAs a detailed working knowledge of how to use OWI and a practical approach to performance diagnostics and troubleshooting that is based on a real experience with the large and complex database installations. DBAs will gain an in-depth knowledge of the OWI methodology and will be able to apply the knowledge to solve performance issues. The OWI is a performance tracking methodology that focuses on process bottlenecks, which are better known as wait events. This includes waits for I/O operations, locks, latches, background process activities, networks latencies, and so on. OWI records and presents all the bottlenecks that a process encounters from start to finish. Removing or even reducing the impact of major bottlenecks improves performance. OWI consists of various dynamic performance views and historical performance data in regards to the wait events. Dynamic performance view provides the statistics on the wait events and the historical performance data, which is collected by means of AWR, ASH, and SQL trace, can provide transition for the wait events. The main reason why OWI was introduced is to troubleshoot performance problems. For this purpose, you must first verify if any performance problems exist in the system currently in use, and analyze whether the root cause of the problem at hand lies with the CPU, memory, and resource issues, or it is an application execution issues involving logical reads and physical reads, so as to be able to conclude if tuning is possible. The problem analysis process mentioned above is divided into a three-step process as follows: find performance problem, find root cause, find right solution. OWI is used in all three steps to provide grounds for the problem resolution. The most critical issue in performance is bad response time. The end user's response time can be divided into network response time and the database response time, of which the latter is the more critical path. In this lesson, we will only focus on the database response time. Database response time consists of the service time and the wait time. The service time is the amount of time a process spends on the CPU. The wait time is the amount of time a process waits for specific resources to be available before continuing with processing, like DB file scattered read, DB file sequential read, latch free, and so on. This formula is based on the notion that at any point, a process is either actively servicing a request on the CPU or is off the CPU and in wait state. You can improve database response time by shortening the service time, the wait time, or both. Oracle debuted the Wait interface in Release 7.012. The wait event information lets you quickly identify the major bottlenecks that plague a process so you can find the appropriate solution to solve the problem. For instance, library cache latch and library cache pin means that a contention has occurred in the shared pool, and the cache buffer's chain latch means a contention has occurred in the buffer pool. The wait event is the best solution to identifying the cause of a wait time for a response time. It was mentioned earlier that OWI consists of weight event, dynamic performance view, and historical performance data. Now, let's take a closer look. As mentioned earlier, Oracle debuted the weight interface in release 7.0.12 with only 104 weight events. The number of weight events quickly grew to about 140 in Oracle 8.0, about 220 in Oracle 8i database, about 400 in Oracle 9i database, and more than 800 in Oracle Database 10G. The most popular version in the current market, Oracle 11G, holds about 1,100 weight events. The growth in the number of weight events with each new release should convince you that the OWI is the preferred tuning methodology.